To create my videos, I have several Raspberry Pi Zeros with an autofocus camera. They are connected to an ATEM Mini Pro, which allows me to easily switch between cameras or computer displays when presenting or recording. Because I wanted to have an easy way to change the zoom level of the cameras, I created a small Java application that can be called through an API to change some of the camera settings. Let me guide you through the code and the setup. Let's first see what's inside my Raspberry Pi camera. So it's a Raspberry Pi Zero, the first edition. You have the flat cable going to an autofocus camera module, and this all fits nicely in a 3D printed housing, which I found online, modified it a bit, and you can find the link in the blog and below this video. And it has this nice holder that you can attach to any default camera screw, and you can still reach the USB and the HDMI. I prepared an SD card with the operating system, a 32-bit version, the light version, because we only need the terminal, no desktop environment. Now let's jump to the device. Once started, we can validate that this is indeed a Raspberry Pi Zero, first edition. And as you probably know, this has an ARM v6 processor, so those processors are used in the first generations of the Raspberry Pi, and I have the full Linux system, the latest version, running on this. And this type of Raspberry Pi only has 512 megabytes of memory, but still that's enough for what we want to achieve with it. Now I prepared this board already with the application and Java, the Zulu version, which is compatible with this ARM v6 processor. So this is a Java 11. And we have a service script which starts the application. It waits until the board is fully booted, so about 30 seconds. Then it calls the Java application with the jar file and runs it as a service. So we can use systemctl to check the status of this service, and you see that it is running successfully with some of the log output, but we can also get the log output from a typical Java logger, and you see that the application is running and started the camera. Now let's dive into the sources. So this is a Maven project. As you can see, I configured it with Java 11, so it also has a dependency to the Jetty server, which is compatible with Java 11. And if you look into the list of dependencies, so not a lot of them are used here. It's mainly Jetty and some test libraries. And for the build, I'm using the Shade plugin, which makes this an executable jar file by defining the main class that needs to be started. So when the application starts, we have the port that the Jetty server will listen on, and we need to initialize the camera service that is responsible for starting the camera and restarting it when the settings change, and the Jetty server to listen to API calls. So here we define which class is used to handle the API calls. And in the camera service, we first have a settings loader. So every change of the settings is stored in the registry. If the board restarts, that the settings are reloaded and the camera is started with the same settings as which were used the last time. And if you apply settings, so first the camera is stopped, it's killed the process, then it waits 2 seconds, and then it restarts the camera with the new settings. Then it also saves these new settings in the registry. So again, if the application reboots or the device reboots, that you have the same camera settings as you had before. And this is the API handler. So if you call the API, it will check which of the parameters that are provided, and if that parameter is there, it will store it in the camera service and then apply it. And there are some helpers here One is to execute terminal commands, the other one is for the registry, and then all the available registry keys are also here. A short demo of how it's running on the Raspberry Pi. So on top you have the logging on the Raspberry Pi itself. At the bottom I'm calling the API with some curl commands, and on the right bottom you see the camera output. So it started full screen, it's a white autofocus camera that I'm using there, and now we zoomed in, so 50% zoom level. And then we can also change the position, the offset position of the part of the camera that we want to see. So we move it a bit to the right. And if we change the Y position, then we will have a lower portion of the camera view. And we can go back to full size. Check the blog post for all the details and a link to the sources. Have fun and let me know how you use this project and what can be further improved and which functionality should be added.